Okay. Today we are discussing about Technos Unit 8 Technos theorem. Unit 8. Unit 8 Technos theorem. Technos theory. NOFF. Thickness is NOFF. theorem. LHUO or EM theorem, Tikhonov theorem. Concepts. Concepts. Simple definition. Concepts. Definition. Definition. So page number 68. Page number 68. Is the definition. Let X be a topological place. Let X be a topological space. Topological space. Let X be a topological space. A class. A class. A class. A class. Class. Script G. Right? Script G. Class script of open sets in X. Of open sets in X. Open sets in X. Open sets in X. Open sets in X is said to be subcover of. Is said to be. Is said to be. Is said to be. Is said to be sub base of open sets. Sub base of. Sub base of. Sub base of. For open sets. For open sets. Sub base of open sets. Page number 68 follows. Open sets. Open sets. Are open subbase for the topology. Are open subbase. Open subbase. Open subbase for topology. For topology. For topology. If the class beta. If the class. The class beta. The class beta. The class beta of all finite intersection. Of all finite. All finite intersection. Of intersection. Intersection of members of script G. Of members of script G. The script G. G is a base for the topology. Is a base for the topology. Is a base for the topology. For the topology. Is base for the topology. Base for the topology. For the topology in X. Is base for the topology in X. in X. Base for the topology 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 in X. Where base for the topology in X. Base for the topology in X. Base for the topology in X. Sharing screen in between distance. Share screen.
Sir, we cannot see where you are writing.
I will log in another desktop. It is creating problem.
Hello.
Let X be let X be topological space. This be expansion. Let X be topological space. Let X be topological space. Definition. Definition. Necessary lines are coming from where it is a domain. N definition. Let capital X be a topological space. Let X be topological space. This is also coming problem definition. There is coming. So I will log in another laptop.
So you are not listening anything. Hello. Hello, sir.
Hello. Hello, sir.
let X be a topological space. Let X be a topological space. A class script G, a class script G, this is script G, of closed sets in X, of closed sets in X, closed sets in X, closed sets in X, closed sets in X is called base for the closed sets, is called is called is called base is called base for the closed sets, 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 base for the closed sets. Base for the closed sets. Base for the closed are closed subbase for the topology. If the class of all complements, if the class of all complements, the class of all complements of members of the script G is a base. Script G is a base. Base means subbase. 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 For open sets in X. For open sets in X. Open sets in X. So for example, page number 68. I'll follow the page number 68. Yeah. For example, so in the real number system, R is the triangular. Beta is the close. Then for example, zeta equal to, minus infinity, comma, minus infinity to B, such that B belongs to set of real numbers. B belongs to set of real numbers. Union, A, comma, plus infinity, comma, plus infinity, such that A belongs to R. A belongs to R. A belongs to R. So based upon this one, so one important one, Jones lemma. Jones lemma. Jones lemma. Jones lemma. Jones lemma. If a class
Sir, some explain, sir.
if a class zeta, if a class beta of sets is closed, of sets is closed, of sets is closed under union of chains. under union of chains, union of chains, union of chains, union of chains, beta has a maximum number, has a maximum number, maximum number, that there exists M belongs to, that there exists, this is there exists symbol, M belongs to beta, such that M is not a proper continued ST, means such that M is not properly contained, not properly contained, not properly contained any other members of beta, any other members of beta. This is called Jones lemma. Next, most important theorem for 10 marks. That is Heinz-Borel theorem. Before proving that, one more theorem you need to do. Page number 70. Page number 70.
Sir, please give some explanation also, sir.
So Jones lemma, this is for short answers. If a class beta of sets in closed under the union of chains, beta has a maximum number that there exists. M belongs to, this is M belongs to beta, such that M is a properly contained any of the member of beta. So theorem statement. Theorem. Prove that every compact subset of, prove that every compact subset of every compact subset of a metric space is closed. Okay. Metric space is closed. Metric space is closed. So, this theorem for 10 marks. So let X comma D, let X comma D, let X comma D be a metric space. Be a metric space. Metric space. And Y a compact subset of X. And Y is compact. CPT means compact subset of X. Subset of X. Subset of X. Compact subset. We shall prove that X to Y is open. Y is open. Let Z belong to X to Y. Let Z belongs to X to Y. For each small y belongs to capital Y, then Y is not equal to Z. Y is not equal to Z. And hence d of y comma z D of y comma z greater than 0. Greater than 0. So g of y means g suffix y equal to, within the set symbol, x belongs to capital X belongs to capital X, such that d of x comma y less than 1 by 2, d of y comma z. So h suffix y equal to, so small x belongs to capital X, such that dx comma z is less than 1 by 2 d of y comma z. So clearly here, clearly y belongs to g of y comma z belongs to h of y, such that y is subset or equal to union of I equal to 1 to n, 1 to n g of yi. And y means I means what? I equal to 1 to, here I equal to 1 to n. Next case. Put h equal to, intersection n equal to 1 to n, n equal to 1 to n, h y j, h y I, where I equal to 1 to n. H is a neighborhood of z. What is h? H is the neighborhood, which is NBD, means neighborhood of z, and h intersection y is subset or equal to h intersection union of I equal to 1 to n, n to 1 to n, gn gy, that equal to union of I equal to 1 to n, equal to 1 to n, h yi intersection gy yi. So and hence h intersection y equal to null set, since hyi intersection gyi equal to null set. So therefore h is open set. Therefore h is open set. Such that z belongs to h, subset are equal to x minus x to y, x minus y, x to y or x minus. Thus, x minus y is open and y is closed. Is open and y is closed. Next, most important here, Haynes-Borel theorem. This is also for 10 mark question.
Sir, what is compact subset?
Compact means suppose team A and team B are there. there is neither team A not getting any point, neither team is not getting another point. Both are tie. So sequentially compacts with another definition. Next, Heinz-Borel theorem. Page number 71. Page number 71. Theorem. Heinz-Borel theorem. HE. This question formation is state and prove Heinz-Borel's theorem. You have to learn statement also. Heinz-Borel theorem. Heinz-Borel theorem. Statement. Prove that every closed and bounded and BDD means bounded. Every closed and bounded subset of R is compact. Subset of R is compact. CPT means compact. Proof. We shall first prove that any interval of the form we need to prove that any interval of the form, in the closed interval A, B is compact in R. Let A, B belongs to R. Let A, B belongs to R. And A less than B. Then the class script zeta, this is known as script G in this set symbol. Closed interval A, X such that the value of X is lies between A and B, means A less than X less than B. Union of A, B. Union of A, left open, right closed. Such that the value of X lies between A and B. A less than or equal to X less than B. Is a subbase for the open sets. Subbase for the open set. Sets in closed interval A, B. Closed interval A, B. Closed interval A, let space. Let script G. Let script G equal to X, B. Closed interval such that the value of X lies between A and B. A less than X less than or equal to B means the value of X lies between A and B. That equal to limit. In the script symbol A, X such that the value of X lies between A and B. A less than or equal to less than B. That equal to this consider this is script G1, this is script G2. Then script G can be written as script G1 union script G 2. Right. Thus, script G is a subbase for the closed sets. Then script G is a subbase. Script G is a subbase for closed sets. For closed sets. In closed interval A comma B. The use of Alexander's lemma before this one. Use of Alexander's lemma. Alexander's lemma. Alexander's lemma. Alexander's lemma. Let tau, this is tau, be a class of subbasic, be a class of subbase, subbasic, closed sets, closed sets with finite inter property, FIP property, that tau is subset or equal to tau is subset or equal to script G and A1 intersection A2 and A1 intersection A2 intersection etc. AN means intersection AN is null set. But here A1, A2, etc. ANR belongs to tau. Here A1, A2, etc. AN belongs to tau. Every member of F of the form, if every member of the member of F of the form, X comma B, then B is the intersection of all members of them. B is the intersection of all the members of tau. All the members of tau. All the members of tau. And hence tau has non-empty intersection. And hence tau is non-empty intersection. Non-empty intersection. Similarly, in the case when every member of tau of the form, every member of tau, every member of tau of the form of the form closed interval a comma x, closed interval a comma x. So let tau is does not subset or equal to script g1, and tau does not subset or equal to script g2, then tau equal to tau intersection zeta1, tau intersection script g1 union tau intersection script g2 equal to null set. Printing mistake there, null set. For conveniency, let me write. For conveniency, we can write. Tau intersection zeta1 script g1 equal to script g equal to in the closure symbol xi comma b where I equal to where I belongs to tau. So where I and j are non-empty sets, where I and j are non-empty sets, and they are non-empty sets, then small I belongs to capital I and the small j belongs to capital J. Then we have xi comma b intersection a comma yi yj if yj is not equal to non-empty, and hence there exists a C such that symbol C such that S means such that C lies between xi and b, where C lies between xi less than or equal to C is less than or equal to b. The value of x is C is lies between xi and b, and C is also and C is also and a less than a less than or equal to C less than or equal to yj. Therefore, C is lies between, that means C is lies between, therefore C is lies between xi less than or equal to C is less than or equal to yj. Thus, yes, remove thus, thus, thus xi is less than or equal to yj, less than or equal to yj for all small I belongs to capital I, comma small j belongs to capital J. Capital J. That implies S less than or equal to T. That implies S less than or equal to T. Where? 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 S equal to supremum of X. X, where S equal to supremum of X. Supremum of where X equal to supremum of X I, where I belongs to capital I. Next. T equal to infimum of Yj. INF means infimum. SUP means supremum. J belongs to capital J. Yj. Yj. Then ST lies between Xi and B. Then ST is Xi less than or equal to S is less than or equal to T is less than or equal to B. The value of S and T lies between Xi and B. And A less than or equal to T less than or equal to Yj. For all, same. For all small I belongs to capital I and small j belongs to capital J. Capital J belongs to capital J. Hence, P belongs to all. Hence, P belongs to all. Belongs to X comma B. As well as J comma Yj. J comma Y. Psi. J comma Yj. Comma Yj. Okay. Therefore, F has FIP means finite intersection property. Therefore, F has non-empty intersection. Therefore, F has non-empty. F has non-empty intersection. Non-empty intersection. Thus, A comma B is compact. A comma B is compact. CPT means compact. This completes the proof, hence proved. Hence Borel theorem. Next, most important theorem, Tikhnov's theorem. One Tikhnov's theorem is there. Before going that, we will discuss one definition. Definition and lemma also. Definition. Definition. Page number 73. Out of your PowerPoint 73. Let Xn, Xa Let X alpha belongs to N. Let X alpha belongs to delta. Alpha belongs to delta. Be non-empty class of non-empty sets. Be non-empty class of non-empty sets. Non-empty sets. Non-empty sets. If X is an element of the product, if X is an element of the product, element of the product, element of the product of X is of X alpha S. Then we write X alpha. Then we write X alpha. Then we write X alpha. X alpha. For X of alpha. X of alpha. For simplicity. For simplicity. For simplicity. X alpha is called coordinate. Is called alpha th coordinate. X alpha is called the alpha th coordinate or component. Coordinate or component. Component of X. Component of X. So for convenience, we write X alpha. For convenience, we write convenience. For convenience, we can write. For convenience, we can write X alpha, where alpha belongs to delta. Let X be the product of. 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 X be the product of. X be the product of. Let X be the product of. Let X be the product of. Let X be the product of. X alpha. Alpha belongs to delta. Alpha belongs to delta. And for each alpha belongs to delta. Define P of alpha. X tends to X alpha. Next, before proving Tipno's theorem, most important compulsory question. We'll prove small lemma. That is page number 75. Page number 75. Lemma. Lemma, what is lemma? Lemma is a sub-theorem. Corollary also sub-theorem. Lemma. Let x alpha. Let x alpha, where alpha belongs to delta. Alpha belongs to delta. Be non-empty class of topological space. Be non-empty class of topological space. Topological space. That's a topological space. Non-empty class of topological space. Non-empty class of topological space. Topological space. And x equal to pi. What is pi? Pi stands for product of terms. Sigma stands for summation of terms. That read as pi means product. Alpha belongs to delta. Alpha belongs to delta. X alpha. X alpha. The product of X alphas. That's the class. The product of X alphas. X alphas. Then the class. Then the class. Then the class. Script G equal to P alpha minus 1 Fn such that alpha belongs to delta. Alpha belongs to delta. Alpha belongs to delta. And Fn is closed in Xn. And Fn is delta. And Fn is closed. Fn is closed in X alpha. In X alpha. X alpha. And Pn minus 1. Pn minus 1. X alpha minus G alpha. Minus G alpha. That equal to X minus. That equal to X minus product of X. Product of X. Till here statement of proof. This proof. For alpha belongs to delta. X minus Pn minus 1 G of alpha. G of alpha. Here is closed in X alpha. Is closed in X alpha. Closed in X alpha. So Pn minus 1 and Pn minus 1. P1 minus 1. X alpha minus G alpha. X alpha minus G alpha. X alpha minus G alpha. That equal to X minus Pn minus 1 and G alpha. Here. So therefore, script G coincides with the class. Therefore, script G is coincide. Coincide means meeting. coincide with the class, coincide with the class, coincide with the class, coincide with the class, equal to x minus pn minus 1 and u p alpha, not n, alpha p alpha, p alpha, p alpha, u alpha, such that alpha belongs to delta. Alpha belongs to delta. And u alpha is open in x alpha. And u alpha is open in x alpha. X alpha. The lemma follows. Thus the lemma follows. This is for 5 marks. Lemma follows. Short answer. So now long answer 10 marks. Technos theorem, most important. Page number 75, same page number. Technos theorem. Technos. Tychonoff theorem. Sometimes you have to learn statement also. State and prove Technos theorem for 10 marks question. The product of any non-empty class statement. The product, prove that. Sometimes they will ask like that, prove that, state and prove Technos theorem, or prove that, or show that the product of any non-empty class, the product of any non-empty class, non-empty class, product of non-empty class of compact topological space is compact. Of compact, CPT means compact topological space. Topological space is compact. CPT means compact. Now proof of theorem. Most important for 10 marks questions. Let x alpha, where alpha belongs to delta, be non-empty class of compact, be non-empty class of compact topological space. CPT means compact, top means topological space, SP topological space is compact topological space, and X be the product space, and X be the product space. Product space. SP means space, product space. For closed sets in X. For closed sets in X. Closed sets in X. Closed sets in X. Closed sets in X. X alphas, that is, I means that is X equal to phi. Alpha belongs to delta. Alpha belongs to phi means product of delta. X alpha. Then the class. in the class fifth G equal to Pn minus 1, P alpha not N, P alpha of A such that alpha belongs to delta. And A is closed subset of Xn. And A is closed. A is closed subset of Xn. Closed subset of X alpha. So is a subbase for closed sets in X. Is a subbase for closed sets in X. Closed in X. We shall use this theorem to prove that let script G is a be a class of subbasic subbase closed sets subbase of closed sets. Then tau is a subclass of zeta. Then tau is a subclass of script G. With the finite intersection property FIP. Before also we did FIP means finite intersection property. Alpha belongs to delta. Let script G alpha equal to A subset are equal to X alpha. Such that A is a closed in X alpha. 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 And P alpha minus 1 of A belongs to script G. Belongs to script G. Then script G alpha is a class of script G alpha is a class of closed sets in Xn. Of closed sets in Xn. Closed sets in Xn. X alpha. Satisfying the FIP. Satisfy the FIP. FIP means finite intersection property. Since X alpha is compact. CPT means compact. So G alpha has non-empty intersection. So G alpha is non-empty non-empty intersection. Non-empty intersection. Non-empty intersection. By choose X alpha belongs to. Choose X alpha belongs to. X alpha belongs to. Choose X alpha belongs to. Intersection A. Intersection A. And A belongs to. A belongs to script G. Okay. For all small alpha belongs to delta. Yeah. Then the element X in the product of X. Then the element of X. Element of X. Element of X. Element of X. In the product of X. In the product of X. Product of X. Element is product of X. Product of X. Defined X alpha equal to X alpha. Define X alpha equal to X alpha. X alpha. For all alpha belongs to delta. Alpha belongs to delta. Is in every member of G. Is in every member of Z. So P alpha minus 1, P alpha inverse of A. A belongs to script G alpha, and hence P alpha X equal to X alpha that equal to X alpha belongs to A. X alpha belongs to A. So that X belongs to P alpha minus 1, P inverse alpha of A. Then script G is non-empty intersection. Then script G is non-empty intersection. Non-empty intersection. Thus X is compact. Thus X is compact. This completes the proof of theorem. Hence proved. This is most important for 10 marks. Okay. So we'll meet tomorrow. Thank you very much. I'm leaving tomorrow. We'll meet on forum. We'll discuss another unit. Thank you.
Okay, sir.